This is a review for the journal slash practice for today. So in the first question we have a reaction that's yielding a certain amount of energy, and based off of what's written that we're burning a sample of it underneath a 500 gram sample of water. If the water is heated so many degrees, how many grams of that were burned to get that result? So what we have is some water, and it's being set on fire through a sample, and we know the reaction for the sample, and we know how much the water changed. So in this case, the water's specific heat is 4.184 joules per gram degrees Celsius. Another way of writing that is that for every 4.18 joules, you get 1 gram of water to change 1 degree Celsius. And based off the question, we know that we're working with 500 grams, and there's a change of 70 degrees Celsius. So we're multiplying by 500, and we're multiplying by 70. So we're going to do the same thing here, multiply by 500 and multiply by 70, and we should get 146,440 joules. So right off the bat, we know that based off the data, there was 146,000 joules of energy in that water. Now in the reaction, which is as follows: 2C5H10 plus 15O2 yields 10CO2, 10H2O, and 3,500 kilojoules. So we're trying to figure out the connection. So we can change this to kilojoules just so that we're working with the same units. For every 1,000 joules, there are 1 kilojoule. So if you have 146,440, over here you should have 146.4 kilojoules. Using the reaction that we have here, 2 moles of C5H10 is 140 grams, and it yields 3,500 kilojoules. We want to know how many grams would yield this many kilojoules. So all we have to do is set our for every statement to that. And what we should get is 5.85 grams. For the next question, we have a reaction between oxygen and nitrogen gas yielding nitrogen dioxide, and it's saying figure out the enthalpy based off of all of this information. So the first thing we got to do is write out a reaction between those two, and what you should get is 2O2 plus N2 yields NO2, 2 moles of them. And we should know by now that nitrogen and oxygen are diatomic. So I gave you guys the molecular structure of NO2, which is N double bonded to an O and single bonded to an O. And there's 2 moles of them. Now oxygen is a double bonded, and there's 2 moles of them. Now nitrogen, to figure out what it is, we need to figure out the valence electrons, which is 10. So we write out a bone structure. and we used up 2 electrons there, so we have 8 more electrons left. Let's put them around one another. And what we find is that each nitrogen has a total of 6 electrons around it. Remember that the bond counts as 2, and we're trying to get a filled octet. So first, let's just take 1 electron from either. So we have a double bond. And now each nitrogen has 7 electrons surrounding them. Once again, we're not quite at an octet, so let's do that one. And now what we find is that each nitrogen has 8 electrons surrounding them. So we stop at this point. So what we have is N triple bonded to N. All of these on the left-hand side are broken and they're positive, and all of these on the right-hand side are formed and they're negative. And all you're doing is filling in the data for the bond energies. So we have 2 O2s and adding 1 nitrogen triple bonded, and you're basically adding a negative or subtracting, either way. Your negative of 2 ON bonds, or NO bonds, either way, 1, 2, plus 2 N double bonded O, or O double bonded N's. And all you're doing is taking the minus of that. And what you should get at the end is 223 kilojoules positive.